This is not a real storm. No hurricane like this has ever existed, but nothing in physics forbids it. We'll start with the most destructive storm the United States has ever recorded, and the most powerful the Atlantic has ever measured. And then, step by step, we'll push the physics of a hurricane to its absolute limit, and watch what happens to 3 real cities along the way. Welcome to Dies Irae Hypotheticals, where we take real catastrophes and ask a single question: how much worse could it get? Everything we show you is built on real science. The first half is what actually happened. The second half is a thought experiment. Every speculative scene is labeled on screen like this. This is not emergency guidance. It's a story about energy, water, and the limits of the possible. Let's begin where the record begins. August 28, 2005, over the bath-warm Gulf of Mexico, Hurricane Katrina explodes into a Category 5. Sustained winds of 175 miles per hour, a central pressure of 902 millibars. But by the time its eye reaches the coast the next morning, Katrina has weakened to a Category 3, about 125 mile-an-hour winds. On the wind scale alone, it is no longer exceptional. The wind scale lies, because a hurricane surge isn't built at the coast, it's built over days, over open water. Katrina had already piled the ocean into a wall. Along the Mississippi coast, that wall came ashore nearly 28 feet high, the highest storm surge ever recorded in the United States. Whole towns were scraped to their foundations. And then there was New Orleans. As the surge pushed into the city's canals, the flood walls failed, 4 of them collapsing below the height they were designed to hold. This was not simply nature overpowering a city. Engineers later called it the worst engineering catastrophe in American history. More than 80% of New Orleans went underwater. The human cost, by NOAA's current count, around 1,092 deaths, and by its earlier official tally, as many as 1,133. The financial cost, about $108 billion in 2005, over $200 billion in today's money. The costliest hurricane the country has ever endured. Remember the lesson of Katrina. It wasn't the strongest storm, it was the storm that proved how a hurricane's size and water, not just its peak wind, decide who lives. Now, how strong can the wind actually get? October 2025. Hurricane Melissa, the strongest hurricane ever reliably measured in the Atlantic Ocean. Peak winds of 190 miles per hour. An aircraft flying into its core dropped an instrument that clocked a gust of mind-bending speed, the strongest wind ever measured inside an Atlantic storm. Here's what's haunting about that number. Scientists have proposed a hypothetical Category 6 for storms above 192 miles per hour. Melissa fell just 2 miles per hour short. The Atlantic has never crossed that line, but the Pacific has. In 2015, Hurricane Patricia reached 215 miles per hour, the most powerful tropical cyclone ever reliably observed on Earth. In fact, 5 storms worldwide have already crossed that hypothetical Category 6 threshold, every one of them in the last decade. So a Category 6 isn't science fiction, it's a line we've quietly already stepped over. The question is, what's above it? A hurricane is a heat engine. It drinks heat from warm seawater, exhausts it high in the freezing upper atmosphere, and converts the difference into wind. The hotter the ocean and the colder the top of the storm, the more powerful that engine can become. Physicists call the ceiling its maximum potential intensity. Today, in the warmest waters, that ceiling sits around 180 to 200 miles per hour. And the damage doesn't rise gently. A storm's destructive power climbs with the cube of its wind speed. Its economic damage climbs faster still, by some estimates, the 8th power. Double the wind, and you don't double the ruin. You multiply it many times over. So here are our rules. To push a storm past today's record, we warm its ocean, and we'll tell you each time exactly how far past the edge of evidence we've stepped. Tier 1 is real, Tier 2 is at the edge of theory, Tier 3 breaks it. This is the scale we actually use, 5 steps from the merely dangerous to the truly catastrophic. Watch the last column. Destructive power doesn't add up, it multiplies. Now let the scale run off the edge of the page. There are no official categories above 5, but the physics doesn't stop there. As the winds climb, the pressure caves in, and the damage goes vertical. Our 3 nightmares all live on this chart: a Category 6, a Category 8, and a Category 10. Tier 1. A Category 6, winds of 210 miles per hour, takes aim at Miami. This is the grounded scenario. Storms this strong already exist. We're simply aiming one at a city that's never taken a direct top-end hit. The first thing to fail is the glass. At these speeds, debris turns Miami's towers of windows into a storm of blades. Building codes here are the strictest in the nation, and they were written for a Category 5. Tier 1 is the storm that finds the gap above the code. Miami sits barely above the sea, on porous limestone that lets water rise through the ground as well as over the seawall. The surge doesn't stop at the shoreline, it keeps coming. A direct Category 6 wouldn't just flood Miami, it would rewrite the map of which neighborhoods can ever be rebuilt. And remember, this is the plausible one. Tier 2. We warm the Gulf by several degrees beyond anything in the modern record, and the ceiling lifts. A Category 8, 265-mile-per-hour winds, stronger than any storm ever measured on Earth. We aim it at the city that already drowned once. New Orleans, much of it below sea level, ringed by levees rebuilt after Katrina to stop a Category 3. This is a storm with 4 times the destructive power of a Category 5, and many times Katrina's own. The post-Katrina defenses are the best the country has ever built. Against a Category 8 surge, they are a garden wall against the tide. The bowl fills, not in days as in 2005, but in hours. The city doesn't flood. It vanishes beneath the lake it was built beside. A storm this size doesn't just hit a city, it redraws a coastline, pushing the sea miles inland and leaving a new geography behind. We are now past everything we have ever observed. One step remains. Tier 3 is different. To build it, we leave the climate behind entirely. Here, physics ends. A Category 10, winds above 310 miles per hour, needs an ocean far hotter than any greenhouse world could ever produce. And to reach the true ceiling, winds near 500 miles per hour, you'd have to heat the sea to around 50 degrees Celsius. Only an asteroid strike or a vast undersea eruption could do that. Scientists have a name for the result: a hypercane. A storm whose winds approach 500 miles per hour, reaching up into the stratosphere itself. At this scale, the equations we trust begin to break down. So treat what follows as pure imagination, anchored to physics by a single thread. We aim that thread at New York, 8 million people, the financial heart of the world. A harbor shaped like a funnel, built to gather a surge. Superstorm Sandy raised the harbor about 14 feet and paralyzed the city. A hypercane surge would not be measured in feet, it would be measured in stories. The skyscrapers would stand. Almost nothing between them would. This is the edge of the possible, and thankfully, the edge we will almost certainly never reach. So let's come back to solid ground, to what we can actually do. None of the speculative storms require us to be helpless against the real ones. Surge barriers can shield harbors. Restored coastal wetlands can swallow a surge before it reaches a city. Stronger codes save buildings, and the deaths in modern hurricanes come overwhelmingly from water, which means smarter evacuation saves the most lives of all. Our forecasts are now astonishingly good. Katrina's path was known days out. The gap was never knowing. It was building and leaving in time. We can't switch off the ocean's heat engine, but every foot of barrier, every restored marsh, every honest map of the risk buys us time against a sea that is, slowly, gaining the upper hand. The strongest storm that never was is still just that, a what-if. The strongest storm that will be is already forming, somewhere warm and patient. Next time, the ground itself, the largest earthquake ever recorded, and how much harder the Earth could shake. Full sources are in the description and pinned comment. If you want to stare into the edge of the possible with us, subscribe, and we'll see you at the next catastrophe.